This course has been conceived as a continuation of the course Structural Design and Scantling with ISO 12215 norm, which is also available in Naval App. That course provided an introduction to the design of both structures and scantling in accordance with the ISO 12215 standard. It focused on composite materials and the application of the standard to sailing yachts.
In the present course, the focus is set on motorboats and multi-hulls. Concerning materials, metals will be extensively treated, and wood will also be discussed, although in less detail in that case. This course constitutes thus an extension of the previous one.
So, in this course, we will briefly review the fundamentals of strength of materials and the basic concepts relevant to marine structural design. This includes the stress-strain core, methods for calculating stresses in beams, and the typical structural elements found in boat construction.
Additionally, the beam and shell theories, briefly introduced in the first course, will be expanded upon here. The Euler-Bernoulli and Timoshenko beam theories will be presented in detail, and Timoshenko's place theory will also be discussed. Next, we will study metallic materials, examining the metallic bond, the crystallographic structures found in metals, and how this affects their mechanical properties. Immediately thereafter, we will discuss some notes on aluminium and steel, the most widely used metals in the boat industry, followed by a brief overview of wood and its characteristics. Specific details on structural design will be addressed after that.
An introduction to the ISO standard will then be provided, followed by a detailed discussion of specific aspects related to metals and motorboats. These concepts will be applied to a real-world example. In this context, we will begin by examining a metallic motorboat case, calculating the design pressures and determining the scantling for both a stiffener and a panel. Next, we will address the topic of multi-hull. As usual, the theoretical aspects of the standard necessary for understanding practical applications will be covered. A key feature of this type of craft is that the standard accounts for global loads, and several practical examples will be presented.
Finally, the application of the norm to wood will be briefly introduced. We will first explain how the norm applies in this case, and then work through an example of panel scantling. Ideally, students will have completed the first scantling course, becoming familiar with the basic concepts of strength of materials and gaining some proficiency in navigating the norm. However, overviews and reviews of the relevant common parts are included so that even those who have not completed the first course can follow along.